Hello, everyone. What I want to do is two examples that are very similar to uh, collected homework 5 problems. So the first is very similar to um, collected homework number 4, and that is actually verbatim in the book 2.2.5S. Okay, so yeah, and this is typical of exam FM problems. They really kind of give you superfluous, maybe confusing information that you don't really need, but thus is life. So Chris deposits 200 into an account at the end of every 3 months at an effective annual interest rate of I for 6 months, for 6 years, excuse me. The accumulated amount, which is the same thing as the accumulated value, at the end of 6 years is X, which is 4 times the accumulated amount at the end of 3 years. So here we include the last 200 deposit at the end of 3 years. Okay. In the homework, you don't. But okay, so find X. Right. So let's do this. And you don't really need a time diagram, but no harm really in doing it. Okay. So just like in the homework, you do not need to figure out what the effective annual interest rate I is. It's completely irrelevant. And that's the kind of point I'm trying to make is exam FM will sometimes say things like that. We have an interest rate of I, effective annual interest rate of I. Well, that's irrelevant. What is relevant is because payments are every 3 months, right? The 3-month interest rate is what's relevant. So let's say J is the 3-month interest rate. Yeah, like I said, I'm not going to solve for I because I don't need it. Okay. So let me draw first the 6-year time diagram. So there's 4 3-month periods in a year, 6 years. That gives me 24 3-month periods. And obvious, but all right, so 0, 1. Okay, so we have 200, 200, 200. Payments are at the end of every 3 months. Sorry, flip back here. Oops, that. Okay, so yeah, we have 24 6-month periods. So we just plug into a formula. We don't know what the 3-month interest rate is, so we can't use the calculator. Yeah, and thus is life. So just plopping into our formula, it's 200 S24J, which is 200 1. I'm not sure what the hell I was writing there. 1 plus J to the 24 minus 1 over J. Okay. Now this amount is 4 times the accumulated amount at the end of 3 years. Okay. So let's do the same thing for 3 years. Okay. So again, there's 4 3-month periods in a year for 3 years. is 12 3-month periods. Don't really need the time diagram, but no harm in drawing it again. So I guess I probably should make it, not that it really matters much, but I'll make it half the size. All right, so 200. They're all 200. Again, this is 6-month periods. All right. So, right, oops, sorry. 100. Okay, so the accumulated value here is 200, same thing, but with 12. Sorry. It's 200 S12 J. And here is the formula. Okay, so I got plenty of room here. That's good. All right, so we are given that this amount here is 4 times this amount here. Could do it in red here. All right, so what I have in blue, you might even be able to see where this is going already. Typically on exam FM, you're going to have to use quadratic formula, which always perplexes me because who the hell cares if you remember the quadratic formula to do pension and healthcare, insurance calculations, but whatever. All right, so yeah, this is the blue. And yeah, like I said, this is 4 times what's in the red. That's what the problem is stating. It's 200, 1 plus j to 12 minus 1 over j. Okay, so what you can do immediately, okay, let me get rid of this blue here. I'll get rid of the red, and I'll multiply the 4 by 200. Obviously 800. I'll get rid of the bracket here. Bear with me a second. Okay, so yeah, let's get rid of this bracket here. 4 times 200, as I mentioned, is 800. All right, so what I do is I'm going to set x to b, or you can set whatever you want, variables, just do x. Let's set this to be 1 plus j to the 12th. Okay. So one thing I also want to do is to multiply both sides by j. Why not? So that goes away. That goes away. Get rid of the fractions here. Because j is j, 3-month interest rate. So what do I have here? Well, you need to recognize that this is x squared. and this is x. Okay, so now this is nice and easy to solve. Let's see if I can. Sorry, it's a bit of a pain, so just bear with me a second. I'm gonna do that. All right, that should be enough room. All right, so first of all, divide by 200 so that I get 4 here, and this goes away. 800 over 200 is 4. And on collected homework 5, number 2, you definitely don't need quadratic formula. They're going to just factor like you will here. All right, so this of course is just 4x minus 4. So this is x squared minus 4x. Just subtract 4x. To subtract the right-hand side. So subtract 4x and add 4. 4 minus 3, or 4 minus 1 is 3. Sorry. 4 minus 1 is 3. Okay, so this is 0. So we have x minus what do we have? X minus 3, x minus 1. Now it's not it's not stated in the problem, but we do not want an interest rate of 0. So we're going to scrap x equals 1, because x equals 1 means j is 0. Okay. That's just weird. Theoretically, I should mention j is not 0. I'll tell you that for the collected homework and the hints, but yeah, j is not 0, so x is going to be 3. Okay. All right. Yeah, so this is 3. Maybe make that look a little nicer. 1 plus j. All right, so solve for j. We do get a very high interest rate if you think about it, but it's okay. Maybe an unrealistically high interest rate, but all right. So yeah, so just solve for j. And we get 0.09587. Remember, this is a 3-month interest rate, so like I said, it's very high, but it's whatever. All right, so last but not least, we can plug. Remember, oh, sorry. Yeah, now I remember why I wasn't going to do x as 1 plus j to 12. Well, that's okay. So remember, the problem originally asks for this quantity here, right? That's basically what they're saying we want. Yeah, you want the accumulated value after 6 years. That's this amount, accumulated value after 6 years. So yeah, I just plug in, or very quickly do this in the calculator. So now that we have j, this is 200, 1.09587, 24 minus 1 over 0.09587. This is getting a little messy. Sorry about that, but so this is 16. You might get a slightly different answer if you don't round and just store what you get for j in the calculator, but it's still off by I think only $2 if you do that. That's 2, not 20 or something else. Only $2 ish. All right, so this is your answer. Again, the problem is asking for the 6-year accumulated value, and that's this one right here. 6 years times 4 3-month periods to a year is 24 3-month periods for 6 years. The other one was the 12 years. Okay. So yeah, the trick is just get your accumulated value formulas. Remember, we had divide by J here. Set X or I think in the solutions to this that I'll put up once we're done with homework, I put S because X was already from before, but whatever. Set a variable to be in this case 1 plus J at 12th. It'll be a little different than the homework, and just get an easy quadratic to solve it. You get J, and that's enough to get what you want. Just plug into your formula here. Okay. And remember here, J is 0.0958. Okay, so let's do yeah, let me go over 2 to 12. It's not particularly hard, but all right. So this is one of these problems I like because you have to use the calculator to solve it. I explain why in full bloody gory detail in the video on the BA2 plus and annuities. As I kind of go over in that video, you can get an equation for I in this problem. If you really, really want to, you can go to an online grapher and solve it. If you're not an actuary major, I guess that's fine. But if you are an actuary major, this is very typical of exam FM problem where you have to use the calculator to get the interest rate. You don't have an online grapher available to you when you take exam FM. And just getting used to the calculator is just extremely, extremely, extremely important. All right, so enough of that rant here. So I have a loan of 1,000, so that means present value is 1,000. Present value is always the loan amount, the loan price, all synonymous. We paid with 12 annual payments of 100 each, starting 1 year after the loan is made. So let's start the time diagram. So sorry, before I do that, it's 3.5% for the first 4 years. So might as well just draw 4. And then I afterwards. Okay. So 100. Oops, sorry, 100. The loan amount, present value is 1,000. Okay, so here I 3.5 0.0035. Sorry about that. And here we just don't know. All right, so what we have to do is we have an interest rate change. So we break this up into 2 annuities. So maybe it's a little easier or more clear if I put 1 more. All right, so the first annuity I'll do in blue. This is nice and easy. So first of all, the present value of all my payments is 1,000. That's what we're given. So 1,000 is the present value of the blue 100A for sorry, 0.035. Okay. Now, the beginning of the first payment period is already t equals 0. First payment period being 0 to 1. So, I better hurry up because I'm running out of battery life here. But I'll be quick. So, yeah, so the present value formula gives me the present value at t equals 0, which is exactly what we want. We always want for the actual present value at t equals 0. On the other hand, I'll do this in green. So the first payment period, or the beginning of the first payment period for the rest of the 8 payments is t equals 4. The first payment period is 4 to 5, and the payment begins at the end of first payment period. Or if you want, you can make this an annuity due, so that the first payment period is 5 to 6. Well, that's a little weird. That doesn't really work, sorry, because you have a payment of 100 at the end, so you really have to fit this as an annuity immediate. So the beginning of the first payment period, with the first payment period being 4 to 5, is 4, and the present value formula always gives you the present value at the beginning of the first payment period. So this is 100A 8I, and we have to discount this by 4 years at an interest rate of 3.5%. Okay, so I'll skip some of the calculations because, yeah, like I said, my battery is dying out. It's this is to the minus. Actually, I'm gonna have to bear with me, get my battery. So just bear with me a second. Battery charger. And if you're wondering what that picture is, it's actually a statue of where I lived in Germany for a year and a half. It's a statue of what's called the Ganzeliesel, literally translates into Goose Girl. Okay. Okay. There we go. Sorry about that. Okay, so right. So what happens now? Sorry, -4. All right, so hopefully that makes sense. So might as well go back to the solution here. Right, so that's exactly what we had. 100A 4.035 plus 100A 8I times 1.035 to the -4. Okay. Let's have a discount the 100A 8I by 4 years. All right, so you just plop things into the calculator. Can't do anything about this, really. You get A8I is 7.26029. So let's figure out what that is in the calculator. Second. And the key thing to remember is to either make the payment of one positive and the present value negative, or present value positive, payment of one negative. If you want to, you can make the payment 87,14422 and then just take 1,000 minus 367, 30792 is the present value. Maybe that's a little clearer. In other words, just don't divide by 87.14422. Okay, let's get the calculator out. Always clear TVM before proceeding with problems like this. All right, so I'll do that where I so it's awkward with the Zoom thing. There we go. Yeah, so I'll take 1,000 minus the 367 30792. I'm using my mouse pad to do this, so that's why it's so clunky. Okay, so I will make this the present value. I'll make it negative. Remember, either the present value or the payment has to be negative, otherwise your calculator gets very angry. And remember, it makes sense. That's the way I remember it, that you either have to loan someone 632.69 to get the 87 14 payments, or you have to give someone the 87.14 payments to pay back the loan of the 632 something. I forget what I had a second ago, but yeah. 14422. That's the payment. 8N. So I just want to check everything. 8 is N. The 632.69 is the present value. 87.1114422. So compute IY. Get the same answer. Remember, calculator always spits out a percentage as an interest rate, and you have to input percentages as interest rates. So this is 0.02208. Okay. Or if you just want to do it with 1 as a payment, let's do that and check we get the same answer. 1 payment. 7.26029 minus its present value. 8N. Slightly off from rounding, but basically same answer. 0.2208. All right, so like I said, not a hard problem, but hopefully that made sense. And yeah, hopefully this helps. Well, good luck on homework 2. Homework 2 and onward. So I'm making this when homework 2 is roughly due. So all right, so long, take care. Bye-bye.